So this is the 2017 Leaving Cert higher level question, and this is a question, it involves logarithms. So it says, sometimes it is possible to predict the future population in a city using a function. The population in Sapphire City over time can be predicted using the following function. And we're given, so P and then bracket T, so that's our function, is equal to this here, and then so that's in our city Sapphire, so that gives the population. So the population in Avalon, so then there's another city and another function for this different city. And then in the functions above, time is in years, so T is years, and T equals 0 is the beginning of 2010. So they're starting off T equals 0, start of 2010, and S and T are constants. S and K are constants. So the population in Sapphire City at the beginning of 2010 is 1,100,000 people. Find the value of S. So the equation for Sapphire is this one here. So SE 0.1 T by 10 to the power of 6. So that's the equation for Sapphire. But we're told at the beginning of 2010, so we know our time. So they said T equals 0 is the beginning of 2010. So our time equals 0. And we're told that the population is this number here. And this function here equals the population. So the overall function is equal to 1,100,000. So we can sub in T equals 0 and let this equal to this here. So SE 0.1, and then that's going to be 0 by 10 to the power of 6 is equal to 1, and this here. So that's going to be S E, which is our exponential. So E to the power of 0 by 10 to the power of 6 equals 100. Then this here. So then that's going to be E to the power of 1 and E to the power of 0, and any number to the power of 0 is just going to be 1. So that's going to be S by 10 to the power of 6 is equal to, so then if I want to figure out what S is, so S is equal to 1 and divided by 10 to the power of 6. So if I plug that into my calculator, so I get S is equal to 1.1. So that's the value for S, and because S is a constant, it's going to be 1.1 in all our values. So now we're going to write down, for the next one, we want to find the predicted population at the beginning of 2015. So our equation that they gave us was this, but now that we know S, we can fill in S is 1.1 E 0.1 T by 10 to the power of 6. So we will know our T. So at the beginning of 2010, they tell us T equals 0. So at the beginning of 2011, T will be equal to 1. The beginning of 2012, T will be equal to 2. The beginning of 2013, T will be equal to 3. The beginning of 2014, T will be equal to 4, and the beginning of 2015, our T will be equal to 5. So we're going to let T equal 5. So it'll be 1.1 E 0.1 by 5 by 10 to the power of 6. So 1.1, and then E is our natural exponential function, 0.1 by 5, and then we multiply this by 10 to the power of 10 power of 6. And then we get an answer of 1,813,593. And we're going to round that down because we cannot get we're rounding this down because we cannot have like a decimal number of for our population. So then in the next question, we are asked to find the predicted change in the population during 2015. So the change is going to be the population at the start of 2015, the population at the end minus the population at the start. So the population at the end of 2015 is going to be the population at the start of 2016. And for 2016, t is going to be equal to 6. So we're going to get our function pt when t equals 6, so that's 2016, minus our function when p equals 5, which represents the start of 2015, so that will give the change in the year of 2015. So what I'm going to have, so we're already after getting the number of people, so if we do p6, so that's going to be our original function, but remember it's this one here because we got s is 1.1, so 1.1 e 0.1 t, so we're just actually t is going to be equal to 6 for this one, by 10 to the power of 6, and then p to the power p5 for 2015, 1.1 e 0.15 by 10 to the power of 6, and then it's going to be p6 minus p5, so that's going to be 1.1 e 0.16 by 10 to the power of 6, take 1.1 e 0.15 by 10 to the power of 6. So I'm just going to work this out on my calculator. So when I work this out here, I get an answer of 190,737, and I actually get a decimal point, but because we're dealing with populations, we're going to round down. So that's the predicted change in the population during 2015.